Hi, this is Mrs. Grizzalfi. I'm on 11.03 notes today. This is geometry, and we're talking about cross sections and rotations. So what a cross section is it's when you take a plane and you slice it through a three-dimensional figure. And what that does is it gives you a two-dimensional figure. So the cross section is a two-dimensional figure. The cross section will be two-dimensional. So what we're going to do is we're going to take some 3D figures and we're going to just kind of slice them off. So if we were in school, I usually do a little Play-Doh lab, and we form the three-dimensional figure out of Play-Doh, and then we take a knife and we slice off the part that we're looking for. So if we want to look at this first section, which is all pyramids, and we're slicing them off. So picture you're built this pyramid out of Play-Doh, and take a knife and you're going to slice it parallel to that base. Parallel to the base. And whenever you do it parallel to the base, you're going to get whatever the shape the base is. So now that you've sliced it, you have two pieces. So imagine taking those two pieces apart and looking at the bottoms of them and where the knife had touched both of them. And they should have the same shape on them. And what we're asking you to find is, what is that shape? What is that two-dimensional shape that you see on the two sides that touch the knife that you've now taken apart? And here it looks like it could be a square or a rectangle. Since it's not marked as a square, we have to assume that it's a rectangle. So this shape would be a rectangle. Now, these make it a little bit easier because you can see where they're slicing the plane, but they also kind of traced out in red here what it looks like. And so you can kind of get a good visual here. What happens though is the questions that you might see later on won't have a picture drawn for you like this. So you have to visualize. And I think that's what makes these really hard to do is trying to figure that out. So now we're going to take a plane and we're going to slice it perpendicular to the base. It's going right through that apex, which is really important. And since it's going through the apex, it's going to cut down and it's going to try to trace it kind of along the outside of the figure. And it's going to create a triangle. And that's only if it passes through that apex, though. My pen is not cooperating today. Only if it passes through the apex. All right, so this one does not pass through the apex. It's slicing it perpendicular to the base. So that's when we're not always going to get that same shape as the base. We're perpendicular to the base, and it's going to cut through right here, which is interesting because this one actually is going to make a trapezoid. So again, if we sliced it right there, straight down, perpendicular to the base, and we took the two pieces apart where we cut, and we look at where the knife touched those pieces, and what shape do we see? We'd see a trapezoid on each side of those. Next one is a prism. So I've got a couple different prisms here for you to look at. Try pausing the video right here and tell me what you think you're going to get when you cut these off, and then you play it and we'll go over them. All right, so the first one is a rectangular prism because it's got a rectangular base it's sitting on. It looks like it could be a square, but it doesn't say, so we're going to assume it's a rectangle. And we're cutting it parallel to the base. So again, anytime it's parallel to the base, it's going to take that same shape as the base, so it's going to be a rectangle. Here, we're going perpendicular to the base. So we're cutting straight down here. So you're going to be forming another rectangle. And then this one is your triangular prism, and you can tell that because we have two congruent parallel bases, and they are triangles, and we're slicing this one perpendicular to the base, which is going to give us another. Actually, sorry, it's not perpendicular to the base. It would be parallel to the base because these are your bases right here. It's not sitting on its base. So when you have a prism, the bases are the two congruent parallel sides. There's nothing parallel to the one that it's sitting on here in this picture. So this, we're actually slicing parallel to the bases. And then it'll give us the same shape as the base, which is a triangle. All right, next is a cross section of a cube. Try pausing the video, see if you can do these three, and then check them with me. So the first one, since this is a cube, we know that this is a square on all sides. So if we slice this perpendicular to the base right here, then we'd still get a square. Now this one, these next two are kind of unique. We're slicing this one straight down, so it's perpendicular to the base, but it's not just along the edge like we did on the last one. It's kind of chopping off this whole corner. So again, if you trace down along the sides, you kind of see what happens. So what we're actually doing is we're cutting off like a rectangular or a triangular prism, because it's got a triangular base up here and down here. Two congruent parallel bases make a triangular prism. But we're not asking you to find what shape you cut off or the prism that you cut off. We're looking for what two-dimensional shape there is when you sliced it down with that knife and then you looked at those flat sides where the knife cut. What shape are those sides? And in this case, they'd both be rectangles. So be careful, because some people say triangles on this, but it's not a triangle. You're not looking at the shape of what you cut off. You're looking at that flat surface where the plane would have cut the two figures. And then this one, we're cutting not parallel or perpendicular. We're just cutting off this little corner of the cube. So again, if we cut off the corner, follow the edges here, and it makes it a little more clear when you see it, what they drew. And that one would give us a triangle. So if you cut it off and then you looked at the little corner that you cut off, that flat piece there, and then the flat piece on the cube where the corner is missing, what shape do you see there? And those would both be triangles. Next up is a cone. Go ahead, pause the video, try these three. So for the first one, we're cutting it off. You can see it kind of is going to be rounded if you go along that cone, but since we're cutting it and it's passing through that base right there, it's going to be flat on the end. So this one's actually a parabola. Then here we're going parallel to the base. So that one's going to be a circle, same as our base. And this one we're going diagonal. So you're going to create here a nice ellipse. There you go, ellipse. So an ellipse, remember, is just an elongated circle. Now for the cylinder, go ahead, hit pause, try these three. For the first one, we're going perpendicular to the base. So that's actually, which is interesting, going to create a rectangle. So if you chop it right through perpendicular to the base of that circle, you would trace along the outsides and it will create a nice rectangle if you looked at those two sides. Here, if we go parallel to the base, again, parallel to the base is going to make that same shape of a circle. And then the last one here, we're going diagonal. So from this corner to this corner, and that one is going to create an ellipse. We go diagonal like that. And lastly is a sphere. So anywhere we cut on a sphere, which is kind of nice, it's always going to be a circle. So any cross section of a sphere will be a circle. So here, I just gave you a couple to practice. Hit pause, try and write out what the cross section will be for these two. So for this first one, you're again cutting off this like corner right here of this rectangular prism. Looks like it might be a cube, but it doesn't specify. And since you're cutting off that entire corner, that's going to create a rectangle. So you're cutting off a triangular prism, but the shape that you'll see will be a rectangle. And you can kind of see that with that purple shaded in area right there. Now this one does have a 6 on both sides, so we know this has a square base for our pyramid, and we're slicing parallel to the base, which means it's going to be a square. All right, so these ones, it's saying draw and describe the cross-section obtained when the sword slices through each 3D figure. Start the slice where the sword rests near the figure and follow it with the arrow. So this one's gonna go down here, and I'm just gonna try and trace where it would cut along the cone. So it would kind of go down, it's going at a diagonal, but the cone is rounded here, so it's gonna create this rounded shape. And you can see start to forming, it looks like it's gonna be forming an ellipse. So to do these, again, it's very hard. It's hard to visualize them, but you wanna try to imagine this knife or sword cutting through, you're tracing along where that's going on the outside of your figure. Let's do a couple more of these. So all these random marks that appeared, get rid of those. Number 4, we have a rectangular pyramid here. So we're gonna go straight down. So if we're cutting straight down, it's gonna follow, we've got, this is the cut right here. It's gonna follow down on each side. And it's actually gonna create a trapezoid. So again, follow the outside of the figure. Follow the outside of the figure. And then this one here, hopefully is a little bit easier. It's a rectangular prism, so we're just dropping it down. And so that will end up being a rectangle. And our last two are a little bit different. So for these, it says determine the shape of the 3D figure generated by rotating a two-dimensional shape about the axis of rotation that's given. Sketch the 3D figure on the graph. So sketch it, describe or name the shape, and then calculate the volume. So 3 things we need to do here, round to the nearest 10th of a cubic unit. So this is kind of like if you have ever been through a revolving door, then so that door is a rectangular shape, but it spins in a circle, right? So the outside that it makes is actually circular. So if you took the whole piece of that door off, then it would be a cylinder. If you ever have used those little, they're like tissue paper things, that kind of waffly with the tissue paper, and they're flat, and then you put them on, like for parties, you might have them as like a little centerpiece, and then you pull them back and they meet together and you paper clip them together and they make a circle, usually little decorations and stuff like that. So it's taking something that's two-dimensional and just rotating it really quick around an axis and creating a 3-dimensional figure. So what they want to know is what 3D figure is going to come from this, and this particular question is asking you for the volume as well. So it says rotate it about x equals -1. So find x equals -1 first. So that's right here. And it's important that we could have rotated around any of those edges they could ask you. So I rotated it here. So that's going to stay put. The axis stays there. It's never going to move. This point over here, we're going to spin that whole rectangle as fast as we can around this green line right here. And we want to know what shape that's going to create. So this point's going to go all the way as far as it can go over here. It'll be 3 away since it's 3 away there. This point can spin all the way to 3 away from the axis on that side. So now we have that whole line. If it spins, that's as far as it can go to the left. And to draw this, we're going to say, okay, well, this point's going to spin over to there in a circle. This point's going to spin over to there. And what do we have ourselves? A nice cylinder. So if you take a rectangle and you rotate it about one of its sides, then it will become a cylinder. And then we were asked to find the volume. So the volume of a cylinder is pi r squared h. So to find our radius here, our axis is right in the middle. So it's 3 boxes is our radius. We count up along the height of the rectangle will give us the height of our cylinder, which is 7 boxes there. Now we substitute in, we've got pi times our radius 3 squared times our height, which is 7. That gives us 9 times 7, which is 63 pi. And then it said to round to the nearest tenth of a cubic unit. So type in 63 pi into your calculator. Gives us 197.9203372 to the nearest tenth would be 197.9 cubic units. And then number 7, we're going to rotate it about y equals 2. So here's y equals 2 right here. So that side of the triangle we're going to keep. It's not going to change. It's not going to move. Everything else is going to spin around it. So this point can go as far as 2 away on the other side, since it's currently 2 away from the axis. This point up here is going to stay where it is because it's on that line of rotation. So this point's going to spin over to here, and then we're going to connect up here, and we have ourselves a lovely cone. So if you take a triangle and you're rotating it about this side right here, especially if you have this right triangle, it will create a right circular cone. And then we want to find the volume of that cone. Formula is 1/3 pi r squared h, and you can get those off of your reference sheet. So our radius here is from our axis over would be 2. We count up, our height is again 7 boxes. So we take 1/3 pi, our radius is 2 squared times 7. That gives me 4 times 7 is 28. 28 times 1/3 would be 28 over 3 pi. So in my calculator, type in 28 divided by 3 times pi, gives me 29.32153,143. Rounded to the nearest tenth would be 29.3 units squared. And that's it for our cross sections and rotations. And I hope you guys are having a great day and staying happy and healthy, math dancing, having fun, loving math, and hope to see you soon. Pi out.